Development and adoption of IPv6 started from 1990s. The internet with IP version 4 was in place at that time. This means that routers did not have the capacity of processing IP version 6, but they did have the capacity for IP version 4. And we know that in a massive distributed infrastructure, it is not possible to upgrade everything simultaneously. Given the situation, the question is, while upgrade of the routers is in progress, is there a way for making IPv6 compatibility at the IPv4 capable routers? This is achieved using tunneling. In tunneling, an IPv6 datagram is carried as payload in the IPv4 datagram, while passing the routers that are only capable of IP version 4 processing. Suppose we have 6 routers along a path. Routers A, B, and E and F are capable of IP version 6 processing. However, nodes C and D are not capable of IP version 6 processing. If routers B and E want to interoperate using IP version 6, they have to use tunnels through routers C and D. To perform this, node B, on receipt of an IPv6 datagram that is to be sent to node F, makes an IPv4 datagram that has the original IPv6 datagram as a payload, and sets itself as the source, and node E, which is the next IPv6 capable router along the path after the IPv4 only routers, the destination of the IPv4 datagram, and forwards this new IPv4 datagram to router C, which is along the path to E. Router C sees this as a normal IPv4 datagram and forwards it to the next hop, which is D. Node D as well sees this as a normal IPv4 datagram and forwards it to the next hop, which is E. Node E receives the IPv4 datagram, sees itself as a destination of the IPv4 datagram, and therefore extracts its payload, which is the IPv6 datagram. Therefore, it can continue forwarding on IPv6 from that point on. Note that source and destination addresses of the IPv4 datagrams are the routers originating and terminating the IPv4 tunneling, therefore defining the tunnel boundaries. IPv6 adoption has been extremely slow. Although the development efforts started in 1990s, we still have very low adoption in the internet. Google tracks the adoption of IPv6 among its clients. The numbers available online show at around 8% in 2016 and around 32% in 2020. Comparing this with the massive changes that have been happening in other areas of network development and adoption in the similar number of years, why do you think this adoption has been so slow? IP is a foundational protocol for the internet. While other changes may affect only a specific use case or a layer, the change from IPv4 to IPv6 affects the core of the network. Comparing to a parallel life example, while changing, for example, an application protocol might be like changing the utilities at your home, changing from IPv4 to IPv6 is similar to changing the foundation of your home while trying to do it without tearing the whole house down. That is a big task, which could not be performed easily and fast. The same reasoning might be used for changing towards IPv6.